Hello everyone, this is Pietro Musoni and I'm going to present to you a functional skeleton transfer. This work is made by me, Riccardo Marin, Simone Melzi and Umberto Castellani from the University of Verona and La Sapienza University of Rome. The aim of this work is to handle a very well-known problem in the computer graphics community, the automatic rigging. Given an unrigged character as input, we want to find the skeleton that fits the best on our input shape. Several works in the past years have tackled this problem with very different approaches, like making the adaptation of an existing rig on a new character, registering from a skinned character to a new shape, or defining a skeleton from scratch, starting from a sequence of meshes of the 3D model. Also, some recent data-driven approaches learn an operator from large datasets of 3D models that apply to the vertices of a new mesh output the 3D positions of the joints. The majority of the cited works requires EV computations, user inputs, or prior knowledge about the domain. Our approach aims to automatically transfer the skeleton using only the surface geometry of the shapes. To perform this, we find a functional representation of the two shapes, and through the functional maps framework, we obtain the correspondences of the two 3D models. Then we find, by an optimization process, an operator that applied to the 3D vertices positions of the input shapes returns the joint position. We name this operator spatial regressor. We define then what we call the spectral regressor. It works similar to our spatial regressor. It is applied on the eigenfunction of the Laplace Beltrami operator defining the shape, namely the spectral representation. This representation is entirely intrinsic, and the regressor can be transferred to the target shape using functional maps. Our spectral regressor is flexible and it can handle very different characters. It can be applied to 3D models with different shapes, poses, level of details, and connectivities. Thank you for the attention. I hope you will join me in the presentation of this work on September the 7th in the Skeleton and Motion paper session.